Step 1 in the spanning tree protocol process is to determine the root bridge. Let's take a look at that in a little more detail. First of all, the switch with the lowest bridge ID. So of all these switches, the lowest bridge ID will make that the root bridge. Now, this may mean that the older switches tend to become the bridge ID. And the reason that is because, remember, first of all, that the bridge priority 32768 is the default. So all of them by default are going to have 32768 unless we change it. Now, the MAC address then is going to become the factor that makes the difference, and a MAC address is made of two parts. The organizationally unique identity, which means who owns the card. So in this case, B42E99 is owned by Gigabyte Technology. And then the vendor ID, that is this last part, is the ID that that vendor gives to that interface card. They usually start with 000001 or something like that, and then increment this one at a time as they manufacture these interface cards. So as long as it's within the same vendor, then this number is going to be lower with the older switches and higher with the newer switches. So unless the vendors are different themselves, these tend to be the older switches. If you buy a bunch of switches at once and you tend to get MAC addresses that are incrementing, then your oldest switch will become the one that will become the bridge ID. You can force a lower bridge ID by changing the bridge priority, and the command here is spanning tree VLAN 1 priority 4096. This can be any VLAN, because remember that spanning tree protocol is VLAN specific. So for each VLAN you can have a completely different spanning tree topology going on. These can be 0 or a multiple of 4096. And I don't remember the maximum number, 16440 or something like that. I don't remember exactly, but it can be any number that's a multiple of 4096. So let's take a look. Let's go back here. Let's take a look at these two diagrams that I have and see if we can determine which one will be the bridge ID. And I'm going to move my picture out of the way here. So in this first diagram, these are all priority 32768 all the way around. So the next thing I would do would be to look at the MAC address, and the MAC address here is AA, and so on. So this has the lowest MAC address of these four switches. So switch 4 here will become the bridge ID, or excuse me, the root bridge, I should say. So over here, what's the root bridge? Well, here you see I've got different priorities, 32768, except this switch up here, switch 3, has a priority of 4096. So even though the MAC address is higher on this one than it is over here on switch 4, switch 3 in this case would become the root bridge.